So now the last part of section 7.5 gets into scientific notation. So this is the primary application of looking at things with exponents and how we can use those to our benefit. So what is scientific notation? Well, scientific notation is used to write a simplified form of a very large or a very small number. A number written in scientific notation has two parts. So it's got a number part and a power of 10. So something like this, 4.25 times 10 to the 12th power. Now, the first thing we've got to learn how to do is make sure we can transform from one form to the other. So we got standard notation, which is just the regular number, and then we got scientific notation, which is something like that. So how do we do it? Well, the first step is to position the decimal point. So you're going to be given a number to start with, and we got to move the decimal point somewhere in the number to start. So it says crop the number down to a number between 1 and 10. So essentially you're going to move that decimal point wherever you need to in the number so that you make a number between 1 and 10. So we're going to see this in action, so don't freak out yet. So that's step 1, just move the decimal point. Step 2 is determine the numeral for the exponent. Count the number of places you move the decimal point. This number is the size of the power of 10. We haven't determined if the exponent is positive or negative yet. We got the numerical value of it. So that's step 2. Step 3 is determine the sign for the exponent. Look at the original number. And again, let me stress this. Original number, not the number you just made, the original number. If the original number is greater than 1, then the sign is positive. If it's less than 1, then the sign is negative. Now, you might have already done this and you have your own methods for doing it, and that's great. Just watch what I do first and see if it makes sense or more sense than the way you were doing it. But whatever works is all I care about. So, no, numbers in scientific notation allows negative exponents in the expression. So again, when we're dealing with scientific notation, negative exponents are okay. So just keep that in mind. Excuse me. So now the first part of this, just want you to convert to scientific notation. So we're starting small, 230. So the first step is to take the decimal point wherever it's located, which in this case would be right there, and we want to move it to somewhere in the number such that it creates a number between 1 and 10. So in this case, we're going to want to move it between the 2 and the 3. So that's going to be your numerical part, 2.3. Okay, so that's done. Now, though, we got to determine what our power of 10 is. Excuse me. Now, we moved it how many places? So we got 1, 2. So the numerical value of it is 2, but is it a positive 2 or a negative 2? That's the last part of this. And that goes back to looking at the original number. My original number was bigger than 1. So that means this should be a positive 2. Now, some of you might say, well, wait a minute, don't we just say if it moves to the right, it's positive, if it moves to the left, it's negative? Sometimes that can get confusing because some people will move it based off of the original number. Some people move it based off of the number they just created. So it depends on which one you're moving it on as to whether or not it's going to be positive or negative. That's why I don't even go there. I like to just look at the original number. My original number was bigger than 1. It's got to be positive. No way around that. So looking at this one, my original number is less than 1. So that automatically tells me that my exponent better be negative. So I don't even have to worry about which way I moved it or anything. Original number is small, smaller than 1. It's got to be a negative exponent. So my numerical part, here's my exponent, or my decimal point. I'm going to have to move it between the 1 and the 7 to make it into a number between 1 and 10. So that part's done. Now we got to get our exponent. So we already know it's negative, but how many spots did we move it? From here to between the 1 and the 7, 1, 2, 3 spots. So 3 spots, so a -3. Done. All right, let's try ones that are a little bit bigger. So what's the number part going to be for this one? It's got to be between 1 and 10. So we're going to have to move our decimal point right here between the 4 and the 5. And then our power of 10, is it going to be positive or negative? It's going to have to be positive, right? The number was bigger than 0, bigger than 1. So that means it's got to be positive. And it's got to go 1, 2, 3, 4, 5 spots. So 10 to the 5th power. All right, one more. So there's the heart of our number. Got to move the decimal point right here between the 7 and the 8. And because it's small, smaller than 1, we know it's going to be negative. And we got to go 1, 2, 3, 4, 5, 6, 7. 7 places. So not anything terrible once you get the hang of it. It goes pretty quickly. Now, just to make sure you have it down, let's switch some numbers back. So what about 6.5 times 10 to the 3rd? What would that be in standard notation? So now remember, exponent's positive, so our number should be bigger than 1. So it kind of forces our direction of which way we're moving it. So hopefully you got 6,500, right? So our decimal point was between the 6 and the 5. So 1, 2, 3. So it looks good. Negative exponent, so it's going to be small. So we're going to have some zeros probably in front. How many zeros do we need? Well, the trick with this is that there's always one less zero than the number of places you actually have to move it. So in this case, they want to move it 4 spots, but we're going to need 3 zeros. And then we can put the 1, 5, 2. So, all right. Not too bad, hopefully. Now the last part of this is actually doing some applications with it, and how does it make life easier for us? Well, calculators unfortunately do the work pretty quickly for us, but sometimes if the numbers are really big, I mean like a lot bigger than these ones, a lot more digits, it won't fit on your calculator. So you're kind of stuck. You can't do it on your calculator. So it's something to think about. So this is the way you could do it, and it doesn't matter how limited your calculator is. So if you use scientific notation to do it, first step is to just get these into scientific notation. So small number, negative exponent. So 2 times 10 to the -2. Bigger than 1, positive exponent. So 3.9 times 10 to the 1, 2, 3 spots. And smaller than 1, so it's going to be a negative exponent. So 1.3 times 10 to the 1, 2, 3, 4, 5. So -5. So that's step 1, just to change them correctly. Now what do we do though? Well, what I like to do is just kind of separate everything that goes together into 2 piles. So the first pile is all the number pieces. So we got 2 times 3.9 all over 1.3, and then we got all our powers of 10. And so that kind of keeps them, separated and just going together easier. So now we can just kind of crunch all of this on our calculator. So if you multiply 2 times 3.9, that's 7.8. 7.8 divided by 1.3, well, that's 6. So that's just going to boil down to a 6. Now for this, again, just be careful. How do you want to start? Now, again, don't always try to get rid of the negative exponents first. That's usually the longer way to go. I would combine across first. Use the product rule first. So we can add those 2 exponents together. So that's going to be 10 to the 1 over 10 to the 5. And now we got to subtract those exponents. So what's 1 minus 5? 1 minus 5 is negative 4. And so that's our answer. So remember, we don't need positive exponents when we're dealing with scientific notation. Okay, let's do it a couple more times. So let's see, looks like 5. So we got 3 times 10 to the negative 2. 2.1 times 10 to the negative 4. 6 times 10 to the positive 2. Okay, so that looks good. Now we got to separate it out like we did over here. So we got 1.05 times 3, 2.1 times 6, 10 to the 5th, 10 to the negative 2, 10 to the negative 4, 10 to the positive 2. Now, like I said, you can do this in as many steps as you need to, but if you can do a lot of combining on your own or in one step, that's great. Just be careful. So if we want to combine just the tops and the bottoms, and let's see what we get. So 3.15 looks like 12.6. 10 to the 5th and 10 to the negative 2nd, so we got to add. So that's going to be a positive 3, right? And negative 4 and positive 2 will be a negative 2. All right. So now we got to divide that. Well, I am pretty confident that it's 0.25. Now what about this one? 10 to the 3rd minus negative 2. We're subtracting those exponents. So is it 10 to the 1? Be careful. Because it's a double negative, it's actually adding it. So it's going to be 10 to the 5th. 10 to the 5th power. Now, are we done? Another buzzer, right? No. And the reason why is because of our front number. Remember, that front number has to be between 1 and 10. So right now it's too small. So we got to fix it. Now really all we're going to do is just kind of move this decimal point over and then readjust the exponent on our power of 10. But how do we do that safely and correctly? Here's what I would recommend. Let's change just this original number. Don't worry about this number. Let's just change this into scientific notation itself and see what we get. So we move the decimal point one spot, so that's 2.5 times 10 to the, it's smaller than 1, so it's got to be a negative exponent, right? Negative 1. But don't forget we still got this 10 to the 5th. Now we can combine these two powers of 10. So we got 2.5 times 10 to the 4th. Now some of you might be able to go right from this step to this step and you understand it and it makes sense to you, and that's great. If you don't, I would highly recommend you write this intermediate step, because then you kind of really, prove to yourself why it's moving one way or the other. So, okay, the last problem is more of the same thing. Let's just try to blow through it pretty quick here though. So 4 times 10 to the negative 4, 5.6 times 10 to the 4, and I'm breaking all my leads, and then 1.12 times 10 to the negative 4 again. So we got a lot of 4s for exponents in here, so how can we tackle this? Well, we still want to separate things out. Now, let me slide up here a little bit. I'm going to use underneath. Now, we can combine these together using the product rule. Just add those up. But negative 4 and positive 4 is 0. so that doesn't really help much. Or we could do it another way. Looking at the -4 in the top and the bottom, they're exactly the same, so we can also do this and just cancel them out. So all we have left is this 10 to the 4 power in the top. So that's kind of nice way to do it too. Okay, so now if we multiply this, it looks like we get 22.4 over 1.12 times 10 to the 4th. And if we divide this out, it looks like we get 20 times 10 to the 4. So, are we done? You better be saying no. And the reason why is, again, the front number is too big now. It's bigger than 10. So we got to make it smaller. So just like we did up here, we can say 2 times 10 to the 1st, because that takes care of this. And then we still got the 10 to the 4th power. So all together we got 2 times 10 to the 5th. So, whew, a lot of stuff there going on. But again, it's very systematic. You just got to gradually chip away at it step by step until you get it down into a nice answer. So that wraps up this chapter. So test is going to be coming up. Review is going to be coming up as well. So keep an eye out for that. All right, we'll see you soon.